Alrighty, so we got two things to accomplish today. Thing number one is want to go through the notes. If we paid attention yesterday, shouldn't take that long to go through the notes. And then thing number two is I've got a stack of stuff to hand back for you today. So if you put your homework packets away, because I don't want to see the pinkness out right now, I want to see just nothing but your note packets out. If you put that away, and then if we start on page 4 with the retrieval, you will have to add this 7 right here and the X part of letter E in order to complete this one. Okay, so you got to add a 7 right there. Add that in there, and then fill in those coordinates, please. So it should be filled in like that. So point A should be at the point -5, 6. Point B at 0, 6. Point C at 7, 6. Point H at -5, 0. Point O at the origin, 0, 0. Point D at 7, 0. And, oops, hold on, that one shouldn't be at 7, 0. That should be a 6. Bad 6, bad 0 all around. Make that better. Point G at -5, -3. Point F at 0, -3. And point E at 7, -3. Yes? Oh, it's what? Well, that should have been. Yep, that should have been a 0. I was looking at that one, but yes, it should have been a 0. It was a bad 0 all around, not a bad 6. There you go. All right, moving on. Consider the two segments AB and CD, given the fact that we have that. Well, we should first probably plot segments AB and CD. So point A would be at 0, 8. So that's 1, 2, 3, 4, 5, 6, 7, 8. So here would be point A. And you got to label it with a letter. Point B would be 9, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2. Puts me right there. 6, 7, 8, 9. Yep, point B is right there. So we can connect those. So there is segment AB. C is at 1, 3. And D is at 9, 15. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Way up there. Then we can connect those. Says that we need to find the lengths of those coordinates, or of those segments. Okay, I'll give you a minute and a half to find me the lengths of those segments. Go. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 127? No, 117. $117 can be divided by 9. 13 times. Yes? 117 divided by 9, is that 13? Yeah? Okay. So I get here that segment AB is 3 square roots of 13. Speak now or forever hold your peace. $117, square root of 117 would be wrong. Decimal approximation of that would be wrong. So I want to make sure that you know how that square root of 117 simplifies down to be 3 square roots of 13. Everybody good on that? Okay. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Should be, wait, 10 break should be 12. Did I count wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, should be 12. My fault. $208. 5216 must go in there. Yep. $113 again. I get 4 square roots of 13 for that one. Yes? Okay. Now we need to find the equations of those lines that contain those line segments. Okay. Well, what's the slope of AB? Slope of AB. Negative 2/3. Negative 2/3. We went down 6, so that's a negative 6. We ran 9, rise over run. That simplifies to be negative 2/3. I would agree with that. What is the y-intercept for line segment AB? It's what? 8. Yep, 0, 8 is the line segment, so B is 8. So the equation of line AB would be y equals negative 2/3 x plus 8. Okay. What is the slope of line CD? What do you got? It is not 2/1. It is not 2/3. is 3 over 2. Yep. Because we rose 12, right? We rose 12. We ran 8. So that's going to be 3 over 2. Okay. Can't get a good one, so let's go with the slope-intercept form. Y equals the y sub 1 for the y value for C was 3. The x value was 1, so it looks like that. And now we've got to simplify that. So that's going to be 3 plus 3 halves x minus 3 halves. What is 3 in terms of halves? 3 in terms of halves. 6 halves, right? Okay, because 6 divided by 2 is 3. So this is going to be 6 over 2 plus 3 over 2x minus 3 over 2. So that gives me y equals 3 over 2x plus 3 over 2 as my y-intercept. Okay. Is AB parallel to CD? Why not? Say it louder. Because they intersect. They cross. Okay? So right away, done. Okay? They cross. Okay? So that's a hard no for parallel. They intersect. Okay? What's another reason why? Ivy, I'm going to cut you off. All right, sorry for cutting you off. What was the reason you were coming up with? Their slopes are different. Exactly. Yes, their slopes are different. Okay? That would be the other reason. But for sure, off of the picture that we made, they can't be parallel because blue touches green. Okay? Right? Are they perpendicular? What? Slopes are opposite reciprocals. Negative 2/3 opposite it is positive 2/3, right? And then flipped over is 3 halves. Okay? So yes, they are perpendicular. Because opposite reciprocal slopes. Okay? Good times. In Unit 6 and 7, we investigated special types of quadrilaterals such as parallelograms, kites, and rhombi. Each of these quadrilaterals has special properties that we prove: parallel sides, equal lengths, equal and opposite angles, bisected diagonals, all that fun stuff. All of that is available to you on the back of your yellow toolkit. All of those properties on the back of the yellow toolkit. Wait, nudge, hint. What do you think you should have out? Your yellow toolkit. Okay. But not all quadrilaterals have a special name. How can we tell if a quadrilateral belongs to one of these types? If a quadrilateral does not have a special name, can it still have special properties? In Unit 8, we'll use both algebra and geometry to investigate quadrilaterals defined on coordinate grids. Okay? Am I special? I don't know. Are we special? I hope so. Okay. Shayla just drew quadrilateral Shay, shown at the right. See how they came up with Shayla and Shay? Okay. The coordinates of its vertices are: point S is at the origin, point H is at 0, 5, point A is at 4, 8, point Y is at 7, 4. All of that's on your paper for you. Shayla thinks her quadrilateral is a trapezoid. Well, what are the properties of a trapezoid? That's it, right? Are supplementary, okay, right? Okay, but means we got to find the slope of all of those sides. Okay? So what is the slope of AH? That's this one right here. What is the slope of that one right there? 3 over what? 3 over 4. Do we agree with 3/4? Rows 3 ran 4, positive 3/4. I would concur that that is the slope of AH. SY. SY is here. What is the slope of SY? Do we agree with 4/7? Yep. I would concur with 4/7. Are those two sides parallel? Yay or nay? Well, not the same slope, so they're not parallel. Okay, so we don't have a trapezoid yet. Okay, do we have a parallelogram? No, because those aren't parallel, and so parallelogram has two sets of parallel sides, so we don't have that. Okay, so we got to try the other side. Now we can observe pretty much that the other side is not going to be parallel, right? Doesn't even appear to be parallel. Okay, so HS is this one right here, this red side right here. That slope, we got to think back to first semester, is undefined. Vertical slopes are undefined slopes. Okay? Because we're dividing by 0 in the slope. Okay? And then we've got AY over here. I got a slope of AY as negative 4/3. Would you agree with me on negative 4/3? Yeah? Okay. Do we have we confirmed we don't have anything? We don't have a parallelogram, we don't have a trapezoid, we don't have a rhombus, we don't have a square, we don't have anything, we don't have a rectangle, right? Okay? All right, so we got nothing here so far. Now it says we need to find the lengths of AH, and so find me the length of, you find me the length of AH and Y and SY. You find me blue and green lengths. I'll find the other two. Anybody come up with the length of AH? 5? Okay. I would agree with 5 there. Anybody come up with the length of SY? Square root of 65? 28, 49 at 16, yes, is 65, yes. I went 28, I don't know why I went 28 there. Okay. What can you tell me about side lengths?
Line AH is the same as line the length of AY.
And HS also? Okay, so we've got 3 sides that are the same length, right? Okay, So if we've got three sides that are the same length, do we have a special quadrilateral for that? No, right? Okay. We don't for that one either. Okay. So we don't have a special one for that. So it's not anything based off of the sides being perpendicular or parallel. It's not anything based off of the sides being their lengths. So if it's nothing, then what is it? What would you give the best name for Shayla's shape? Quadrilateral is the best name that you could come up with. Yep. Okay. It's a quadrilateral with one right angle, but that doesn't do me any good because there's nothing special about just having one right angle. Okay. Okay. Love it. What I would like you to do now is I would like you to turn to page 6, and I would like you to complete page 6 here. Consider the following quadrilateral ABCD with those 4 coordinates. Find the best name for it. So that means you're going to have to find the slopes, and you're going to have to find the lengths, and you're going to have to do all of that fun stuff. I'll give you a few minutes to get that completed right now. All right, 1, 4. 1, 2, 3, 4 should be right there. That was A. B, 6, 4. 1, 2, 3, 4, 5, 6. C is 9, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 6, 7, 8. And D is 4, 8. 1, 2, 3, 4, 8. Okay. All right. So we've got let's go with that one, and then let's go with that one. We'll just keep following the color scheme around. I love that. Love that plan. I'm excited to be part of this plan. And then we got that one, and then we've got that one. There we go. Okay. All right. So I'm looking at this one, and I'm saying to myself, my blue slope, AB, is 0. I didn't rise, but I ran 5. 1, 2, 3, 4, 5. So my length is 5. Agree with me on those two? Yeah? Okay. All right. CD is next. That's red. That also has a slope of 0 and has a length of 1, 2, 3, 4, 5. Sweet. A length of 5. Okay. What can you tell me about AB and CD? They're parallel right now. Yes, they're the same length, but that doesn't tell me anything right now, but I at least have one. So minimally, we are at a trapezoid, right? We have one set of parallel sides. Okay. All right. BC, slope of BC, well, ran 3, rose 4, so that's going to be 4/3. Agree with me on that? Okay. All right. Length of BC, well, that's going to be 3 squared plus 4 squared equals C squared. 9, 16. C squared is 25. Take the square root of both sides. 5 is C. So that one's also 5. Okay. That helps out. AD next. There's 4. There's 3. So that math is going to be the same. So that one's going to be 5. And then the slope is going to be 4/3 again. So what can you tell me about BC and AD? They're parallel first, right? Okay. Then they're also equal, right? Okay. So we have 2 pairs of parallel sides, right? So now instead of it being a trapezoid, we're at least a parallelogram. Okay? So because of the slopes, we're at least a parallelogram. Okay? Are we anything more than that? We're a what? We're a rhombus because they're not perpendicular, right? And all of the sides are the same. If we would have had perpendicular sides and all the sides are the same, then we would be a square. But because we don't have the perpendicularness, we are just a rhombus. Okay. Any questions? Homework tonight is going to look very much the same as what we had today. So number 1, we have some rotations and we have some of that circular learning that we had from unit 6 and 7. So you might need some what do we call that paper? Tracing paper. I couldn't think of tracing. I was going with contact paper, and I'm like, okay, it's not contact paper, but yeah, it's tracing paper. So you might need some of that. Yep, there then too. Okay, so we got that. That's number 1. Okay, what do we got for number 2? Number 2, we want the exact perimeter. Does that mean what? Do you get to use your calculator? For exact perimeter? Do we want? Should I see a decimal there? Is what I'm asking. No, it says exact perimeter. That means you leave it in radical form. Okay? Exact means you leave it in radical form. It even says that right after it. Leave answer in radical form. Okay? Perimeter, perimeter, perimeter. Some good perimeters there. I like that. Adding up all the sides. One of these rectangles, again, that we love so much. And then you also have to find HD. Okay? HD is this line segment right here. This is line segment HD. Okay? You've got to find the length of that. Notice how it's a rectangle, right? That means that this makes a right triangle here or here. Okay? So you got 2 right triangles to choose from. You just have to find those side lengths. And that's it. Maybe there's more on that one. I feel like there's more on this page. Just one more of that where you got to find DA. So it's the same diagonal, just a different one. Okay?